Welcome back to part 2 of the DP50V5A power supply. This is where we take the 3D printed enclosure, the module, and some wires and put it all together. Oh, and then we test it. Before we get into that, I'm just going to show you a little bit more CAD of how I created the opening for the module to clip into. Now, the only thing I've skipped here is the cutouts for the spring clips that hold the module in. So I did a similar thing to what I've done, what I did with the other with creating the bottom. So I've actually used the rear plane of the PSU module. So if I hide these other guys here, so what I did was I came in here and I selected this surface and I created a sketch from that. I then used that on the enclosure top to create a cutout, but I did one extra thing, and that is I used an offset modifier in the sketch just to give me that clearance around there that I wanted, that 0.5 millimeter clearance. So I gave it a 1 millimeter offset, which is pretty easy to do. It's in the sketch menu here, offset. Okay, so I offset that sketch, and let me just hide that again, and then to make the spring clip able to clip in here, I added this, which is a little bit difficult to see, but it's an overhanging edge here for the clip to pop into. So they're the kind of real sort of detail-y things that make the difference between a good working design and something that you're going to need to hack away at with a Dremel. So it's a good idea to do these things in the CAD model if you can. Okay, I'm not gonna lie about this. This first print that I did of the enclosure really didn't turn out very good, and you know, you can see there's a lot of sort of, it's like flaky. It's really interesting. This is a filament I hadn't used before. It's a PLA filament I hadn't used before, and it just really hasn't adhered to itself very well in the printing process. So I made a replacement and basically just increased the temperature to try and get some better interlayer bonding on this. The module does fit really well, and I just want to open the holes up here to fit in the power. That's the power inlet, and on the previous version I used these plastic threaded terminal posts, and this one just minced up, like, you know, so easy. I thought I'd ditch those and go with these. Banana plugs will still fit in the front, and what I like about them is that they've got a really big, generous hole here, and this will really clamp down on a cable. That's one of the things I dislike about these type of posts. You know, you want to put something on the post, you've got a little tiny hole there, so the temptation is just to wrap the wire around there and wind the thing up. Invariably it doesn't stay put. So I'm going to go with these, which are more or less speaker terminals. So let's give this a red hot go with the old Christmas tree bit. And that's cutting a lot better, and it's not delaminating, which is a good thing. You just want to take it easy with plastic. It'll, if you run the drill too fast, it'll really chop it out, or melt it worse. So just go nice and steady when you're drilling a 3D print. You know, 3D prints aren't perfect. They'll have lamination. They've got laminations all the way through them. So you know, first off, when you're setting up a 3D print, you should think about where those laminations are, or how they're forming, and what that means for the strength of your print. I printed this sitting like that on the build surface. Okay, so my layers are going through at an angle, so it's a good idea to have a think about that when you're setting up a 3D print. Sometimes it can't be helped. You know, the way that you orient it on the print bed. You know, you don't have a choice. It might not be practical to do it in the ideal orientation, but anyhow, do your best. Okay, so what do I want here? I want a little wrench. Sometimes you can get a wrench or a spanner into these areas, and sometimes you can't. When you can, you should use a spanner. Okay, so that's pretty good. That's good for our first one. Probably the only downside of using these posts is that the black here for negative, you know, isn't particularly stand out, recognizable, not the way it is on these type. But I guess that's just something where we're going to have to pay a bit of attention when setting up the leads. So get all these put together. And this is so much better than those plastic ones. They just chopped out without any kind of encouragement at all. Okay, so that's that. Ah, this one does not want to go on there. Okay, so here we are. I'll just put this on here as a locking. Might actually be easier to do that with a pair of pliers. Even though I don't recommend such things. There we go. It's going to be easier to nip those up with the pliers. Okay, so there's our terminal posts, and now we'll put in the DC socket. Now this takes a pretty big hole, so I'll just check that as we go along rather than make a mistake. I'm going very slowly. I might just let that chamfer in a little bit using the Christmas tree bit. Now I'm getting a little bit of that delamination again in there. Like that. Not as bad as last time though. I just couldn't. I wasn't happy with how that turned out last time. I couldn't live with it. Okay. So just get those cleaned up a little bit. An actual deburring tool might come in handy doing something like this. That. Now, I remember fitting this to the previous version, and it was a little bit tight. I might have the same problem here. I might have to go a little bit deeper with the Christmas tree bit. That might cover it. Keep forgetting I've got to work to the camera. Work to the camera, Benny, work to the camera. There we go. There's a few things here in the workshop that I would never do without, and one of them is my little cheapy scalpel that I got as part of a toolkit with a 3D printer that I bought. So there we go. That's got that one. Okay, so there we are, that's all done, and now the other thing is we've got on our little module here, we've got some clamp terminals, and it's a good idea when you're stripping wire for clamp terminals. Don't be tempted to tin these wires with solder, okay? Because what happens is that when they go into the clamps here, you'll wind them down and they'll fill tight. But then over time, the wire loses, or the clamp loses tension on that tinned wire. Mainly because the solder kind of flows under the pressure, so you're better off not to tin wires that are going to go into clamp terminals. So a little bit of a twist is okay, just to keep them tidy as you poke them in. I might have to slacken these off a little bit. And so these are the output wires. I just want to make sure that I don't get any strands of wire poking outside of the clamps. So basically, what you want is you want to see the wire, the bare wire, go all the way down into the clamp, right, and just the insulation showing. But whatever you do, don't clamp the insulation in here. Clamp the bare wire, and if it's too long, I suspect this one is, grab your side cutters and just trim that so that it fits down into the clamp, and just shows some insulation at the back here. All right. Okay, so I absolutely certain on this. I think I've got the wrong size screwdriver. So get that one instead. So should be able to get a reasonable amount of tension on these. Don't overdo it, of course. Okay, so that looks pretty good. Give them a tug, make sure that they're actually clamped in place. And then do a little tidy up here. Okay, so over to our enclosure now, and this is the moment of truth always, is if the pre-made component fits into the self-made component. So just as a demonstration, those little clamps have clamped in where they should, and so it is possible to remove the unit again. So that comes out nice and easy, which is a good thing. So anyway, we'll finish off putting these wires into the terminals. And what I'm intending to do, fire up the iron. What I'm intending to do is solder onto the back of these terminals, or the posts there, just to make absolutely certain that I've got a good connection. I don't think it's a good idea. It wouldn't be a good idea. Well, the other way you could do it is put a terminal, like an eye on it. So you could crimp an eye onto that, and then thread it onto that threaded post and wind up the lock nut on it, which is a good way to do it. But you know, under the circumstances, this is pretty much a one-way situation, and I'm going to just hopefully put this together once and not have to revisit it. Okay, so in she goes, clip. What a lovely sound that is. And iron's on about 375 degrees C. And I'll just tin these posts up. They're going to absorb a fair bit of heat, so there's going to be a lot of heat go into that before the solder starts to flow. And I'm going to try and keep the solder off the threads here. So actually, what am I doing? This is a bodge in progress here. I really should be putting some heat shrink on these connections. A bit on there, and piece on there. I'll leave the heat shrink gun, well, hot air gun. Lack of prep there. Tragic. Okay, so I want to heat shrink these, so I'm going to solder these on so that they're running on this axis. Okay. Now if you find when you're trying to do a job like this that you know you got the iron on there forever and it's not melting, just get a dab of fresh solder on there, and that'll help with the heat transfer. And anybody that's done any soldering will know that you need 3 hands for soldering, and you can get those little third hand units, which are quite handy with the little clamps and stuff on them to hold things while you solder them. Another really good soldering aid is a lump of blue tack. So seen a lot of people do this. Just wedge the item in the blue tack, and there's your third hand right there. Okay, so let's just double check all of our pluses and minuses. Okay, so that's in plus, in minus, that's correct, and out plus and out minus, yes, that's all good. Don't want any smoke to come out. And then let's just throw this heat shrink into position, and then we're pretty much going to finish off. Okay, no need to linger too long with your hot air. Now the moment of truth. We just have to power it up and test it again, just to make sure we're getting the same sort of results that we were before. Okay, so I've got my power supply plugged in, and there we go. We have splash screen, and we're up and running right there. It still retained the settings that I did in the previous vid, and so I just want to check for polarity and obviously correct voltage coming off the supply. So hit her up, 5.01 saying reading there, and 5 reading on the multimeter, which is pretty darn good, and polarity is correct. Reading plus, not minus, on the multimeter. So happy days. Now, why do I want this 5-volt power supply? Well, I'll give you a hint. It involves these. And no, I'm not building a robotic Roy Orbison. Okay, so till next time, onward and upward.